Welcome to Math All-Star. In today's lesson, we are going to discuss a powerful and practical technique in number theory. Finding the last digit of m to the nth power is usually easy. However, many students have difficulty finding the 10th digit. Although this type of problem can be solved using regular mod methods, it can be solved using some special tricks. This is what we are going to discuss today. Let's show the trick, then give a few examples in the next few slides. The trick depends on the last digit of m. The most basic scenario is when m's last digit is 1. In this case, we just need to multiply the 10th digit of m with n. Then, the units digit of the product is the answer we are looking for. We will show an example in the next slide. When m ends with 3, 7, or 9, we can convert the problem to the previous case by some simple transformations. For example, the fourth power of 3 is 81, which ends with 1. We will discuss this in more detail later. The cases when m ends with 2, 4, 6, or 8 are more complicated. To solve these cases, we may need to rely on the fact that any power of 76 ends with 76. It will become clearer to you when we discuss an example later. We haven't talked about the cases when the last digit is 0 or 5. They are not covered in today's lesson because these two cases are relatively easy to solve. They usually do not require any special techniques. Before we continue on to examples, please take a moment to review the summary. You may pause the video and take some notes. Okay, let's discuss our first example. What is the 10th digit of 321 to the 123rd power? Please pause the video and try it yourself based on the trick we presented in the previous slides. When you are ready, resume the video. When the base ends with 1, we just need to multiply its 10th digit with the exponent. The product's unit digit is what we're looking for. Because we only need the unit digit of their product, we just need the last digit of the exponent. Therefore, in this case, the result is 2 times 3, which gives us 6. Let's check our result using Wolfram Alpha. The answer is indeed 6. Did you get the correct answer? If you want to know why this trick works, check out the link in the description or go to www.mathallstar.org. Be sure you are very comfortable handling this case before moving on. All the following examples will rely on this technique as a basic building block. Before we present the next example, let's review some basic facts. Can you figure out why I'm mentioning them here? The secret is that all of them end with 1. We have already learned how to handle the case when m ends with 1. Therefore, if we can convert a problem to something that ends with 1, we will be able to obtain the result quickly, right? Let's look at an example. What is the 10th digit of 123rd to the 321st power? Please pause the video and try it yourself first. The answer is 2. Let me explain step by step. First, we can safely discard the 1 from 123 because we only need the last two digits. Then, we know that the fourth power of 3 ends with 1, so we transform 23 to the 321st power to the product of 23 to the 320th power and 23. Now, how do we know that the first term equals something ending with 01? Think about it. Pause the video if you want to. This is because we know that 81 to the 80th power must end with 1. Its 10th digit can be computed using the trick we discussed earlier. It equals 8 times 0, which is 0. Now the rest is straightforward. Before we move to the next slide, let me point out an important observation. They are all related to the power of 3. This is important for handling the next case. When the base ends with 2, 4, 6, or 8, a bit of maneuvering will be required. To understand it, let's first present a few simple facts. First of all, any power of 76 will end with 76. This is a well-known result. In fact, 76 is the only two-digit even number which has this property. The other two-digit number with this property is 25, which is odd. Next, we know that the square of 24 equals 576. Hence, if we can find something ending with 24, we can convert it to the case ending with 76. Let's take one step further. It is well known that 2 to the 10th power ends with 24, right? Are you starting to see that everything's connected? This means that we are likely to be able to handle any power of 2 using this trick. Now, let's recall our previous example when we handled cases ending with 3, 7, and 9. We noted that they are all related to the power of 3. Here is our third example. What is the tens digit of 312 to the 123rd power? This problem is more challenging than the previous two. Do you want to have a try first? To solve this problem, we should first try to factorize the base into 2 and 3, and then try to apply the result of the previous two scenarios. This is what we're doing here. Discard 3, the hundredths digit. Then factorize 12 into 2 squared times 3. Expand, then try to find the 10th power of 2 and the 4th power of 3. Next, expand 2 to the 10th power into 1024 and 3 to the 4th power into 81. Transform 1024 into 24. Rewrite the exponent of 24 into 2 to the 12th power. Meanwhile, by applying the first trick, we know 81 to the 30th power ends with 01. Finally, we have the result as 76 times 64 times 1 times 27. There are a few other tricks we can use to further simplify this expression, but the answer is already within sight, as you only have to keep the last two digits during any intermediate step. This concludes this tutorial video. There are quite a few similar problems in math counts, AMC, and even AIME. I hope you can quickly and correctly get the answer next time you come across such a problem. If you have any questions or comments, please feel free to contact us. Our website is www.mathallstar.org. Thank you.